Problem number 21. Along a straight road, a car moving with a speed of 130 km per hour is brought to a stop in a distance of 210 meters. First question, find the magnitude of the deceleration of the car. And the second question is, how long does it take for a car to stop? So here you have to find the two answers. In the first part, we are going to find the acceleration A value. Actually, it's a negative of acceleration. That's the reason they give deceleration word, okay? But in the second part of the question, we are going to find the time, how much time the car need to take stop. And for that, first of all, we have to write what is given in the question. So let's see what is given in the question. The initial speed of the car is given. So what is initial speed? Vi equal to 130 kilometer per hour. We have to convert this kilometer per hour to meter per second. And when the car is about to stop, its final speed is 0 kilometer per hour or 0 meter per second. And then how much distance it's covered, which is 210 meter. Now we have to convert this kilometer per hour to meter per second, and for that we have to use the conversion equation. 1 kilometer, which is equal to 1000 meter, and 1 hour, which is equal to 3600 second. Now kilometer get cancelled with this kilometer, hour get cancelled with this hour, and we will get the answer in terms of meter per second. So let's see what's the answer here. 130 multiplied by 1000 divided by 3600. We got the answer here as 36.11 meter per second. So we consider the final speed as meter per second. Now we have to find the acceleration. For that we have to use the three equations of motion with constant acceleration, which is v final equal to v initial plus at. And the second equation is delta x, which is equal to v initial t plus half at square. And the third equation is v final square, which is equal to v initial square plus 2 into a into delta x. So these three equations are very important for solving this type of question. Now we have to find the value of a. Actually here for finding the value of a should be negative, but we have to use one of this equation. For that we have to compare what are the informations we have in our hand. So in our hand, what are the data we have? We have the initial speed, we have the final speed, we have the distance covered. There is no time. That means if you see the first equation, there is a time information was there, so it's not possible to use the first one. And likewise the second equation is also not possible. Again the t value will be there. But if you see the third equation, there is no time, so we can use this equation for finding the acceleration. So what I'm going to do, I'm going to use the third equation, v final square, which is equal to v initial square plus 2 into a into delta x. So you have to rearrange this equation in terms of a. So if you rearrange, what you'll get, a equal to v final square minus v initial square divided by 2 into delta x. Now I'm going to substitute the value. So for initial speed, for final speed, it's 0 square. Your initial speed is 36.11 square divided by 2 into 210. Now let's see what's the answer here. Minus 0 minus 36.11 square divided by 2 multiplied by 210. We got the answer here as minus 3.10 meter per second square. So that means this is a negative of acceleration, which is called as deceleration, but they ask you to give only the magnitude value. So that means the magnitude value, the absolute value of a, which is equal to positive 3.10 meter per second square. Clear? And in the second part of the question, how much time the car take to stop? That means we have to find the value of t. Again, we have to deal the equation, which is v final equal to v initial plus at, delta x, which is equal to v initial t plus half at square, and third equation is v final square, which is equal to v initial square plus 2 into a into delta x. Now what are the informations we have? We have four information: initial speed, we have final speed, we have delta x, we have even acceleration we got from the first part of the question. By using this, we have to find the answer for B. So if you see the first equation, which will be exactly suitable for getting the answer for the time, so I'm going to use this equation. So V final, which is equal to V initial plus AT. So we have to modify this equation in terms of time. So therefore, time equal to V final minus V initial divided by acceleration, and your V final is 0, your V initial is 36.11 divided by the acceleration. Here, for substituting the value of A, you should not use the positive value. We have to use the actual value of A. What is the actual value? Which is minus 3.10. So by that, this negative get cancelled with this negative, we will get the positive time. So 36.11 divided by 3.10, I got the answer here as 11.648 seconds. If you round it to two digit after the decimal, t equal to 11.65 second. So this is the answer for the second part. That's it. Thank you.